More gas law problems. Here is volume. Liters is a measure of volume. Temperature is it's a measure of temperature. Now, before we start, we're going to we need to add 273 to this to turn that into Kelvin. Can't use the Celsius scale, and these gas laws are all proportionalities. So you need to have absolute scales on all of these. So 325 plus 273, we'll turn that into kelvins, which is 598 Kelvin. And that'll be our temperature. It looks like the temperature is going to change, so let's label that T1, and that's going to be V1. So we have a change in conditions here, so you can use the combined gas law. This is going to be T2. All right, after we add 273 to that, this is actually a room temperature. It's going to be 298. Whoops. 298 Kelvin. And the question is asking, what is the volume? So the question is asking for volume, V2. All right, so you could use the combined gas law, or this is also known as Charles's law. But as I've been doing for all these problems, I'm going to use the ideal gas law, PV equals nRT, move all the constants to one side. All right, so it says pressure does not change, right? And then R is a constant, and the number of moles didn't change. So if we put all the variables on one side, so in other words, divide by T and divide by P, all right, we are going to get V over T is equal to NR over P. And so this is all going to be a constant. All right, so we can say V1 over T1 is equal to V2 over T2, all right, which is again also known as Charles's law. All right, so since we're looking for V2, I'm just going to rearrange this here to solve for V2. It's going to be V1 times T2 over T1. All right, so now we can just plug in our numbers. All right, V1 is 6.80 liters. T2 is 298. Whoops. Kelvin. And the initial temperature is 598 Kelvin. Kelvins are going to cancel out. Let's punch these numbers in. 6.8 times 298 divided by 598. Get 3.39. Get three significant figures here. And the unit we have left is liters.